I'm going to be talking about advances in storage fabric management. Basically, we're working on a new project called the Open Fabrics Management Framework as part of the Open Fabrics Alliance in conjunction with SNIA, DMTF, and the CXL Consortium. So as part of the agenda of my talk, I'm going to be talking a little bit about current network fabric challenges. I'll be talking about why we're basically making this new Open Fabrics Management Framework, and then I'll be talking about the objective of the framework, the participants, current work, and then I'll do a little bit of proof of concept, showing some of the demonstrations that we've been doing. This is a layout of basically a disaggregated computing setup. We've got different endpoints. We've got with fabric adapters. We've got media controllers, memory domains. A lot of the same stuff you've seen in the last two talks, just laid out a little differently. You have memory. For instance, a memory component will be made up of memory, for instance, chunks, and each chunk will be able to communicate using Swordfish and Redfish. And you've got the same thing with fabrics, fabric adapters, chassis, media controllers, and what we want to do is we want to be able to pull all that together so you can have a client and you can have a resource, and we want to be able to mash those together by using the link-ups using fabrics. And so we'll have like composers and things like that talk to the to one master root service to make all those linkages happen as you need them to. Right now, somebody made this up in my working group. We have a lot of different fabrics. We've got Ethernet, we've got InfiniBand, we've got OmniPath, we've got Gen Z. We've got all these we've got all these fabrics. And nobody seems to be able to make one common interface for everything. So you get, when you want to build a system, you have to account for what somebody might want to have in their flavor of network, and then maybe their flavor of extensions. For instance, somebody might have some hardware interface that does computations. You may have somebody that has a certain protocol, and you've got to deal with that when you're building your systems. What we're trying to do is we're trying to make one API using Redfish and Swordfish that you can talk to in an abstract manner, and these different fabrics and these different vendors can make an agent that will communicate their protocols and their types of extensions as they want to expose them to this API using Redfish and Swordfish. So we're trying to make everything unified. It'll make it simpler, and it'll add multiple things like aggregation. You can aggregate multiple fabrics together. You can do quality of service using different fabrics and fabric components. You can build, in the end, you can also link up resources to clients. This is a new version of our framework. On the left side, you'll see clients, and those clients can be things like containers, is one application that we're looking at Sandia. containers with, and you can have container engines talk to a management layer through an API. You'll see we have composability layers, and then we've got the management layer, which is the OFMF. You can check remote inventory. You can check things like the fabric consistency. You can authenticate, because you can do things with authentication and access controls. It'll gather event logs, and do, obviously everything goes through a Redfish tree management and Swordfish. So if you've got storage components over on the right side, you can gather all that information and bring it back into one central repository, which ends up being the OFMF. And on the right side, you'll see we have put together agents. Those agents talk down to whatever fabric manager you have down there. For instance, if you've got InfiniBand, you'll have your InfiniBand fabric manager. You'll have one for Gen Z. CXL has a fabric manager, and it'll talk down to those. They can associate resources that are linked up to that fabric. You can communicate all that back, all the resources, all the fabric information, all back to that OFMF. And then we've been discussing over the last few weeks, we were trying to figure out, okay, now what does the fabric manager need to know, and what does the fabric agent need to know? Because some fabrics have fewer capabilities than other fabrics. For instance, InfiniBand, OmniPath, and Slingshot and Ethernet won't know and aren't designed to know what kind of memory components you have there. But CXL and Gen Z are more capable in that manner. And so those can you convey information up to those agents and also to the fabric managers. And then, but in all cases, even if the fabric doesn't have that information, doesn't need to know it, the OFMF will. So if you got an InfiniBand fabric with a GPU or a field programmable gate array or a memory component, you can convey that back to the OFMF. And then on the left side, let's say I have a container engine. I'm using my own stuff because our use cases, we're working on this right now. You can go over to the left side and gather things like, okay, I have a container, it needs to know, it needs 6 GPUs on the fabric, and it needs to have NVMe over fabric. I need these components. You can go over there to the OFMF and say, okay, I need this. Give me what resources are available on the right side, and then talk to the agents and associate everything that it needs to do over on the right side, and then communicate that all back through to the container engine. And that container gets spun up by the container engine and has all the resources available. And as soon as it's done, it tears it down and it goes back, everything gets communicated back through. CXL can do, has the ability to associate multiple CXL and PCIe connections through its bus, and we're also working on doing some scaling up of that. And then Gen Z, same deal. Gen Z has a lot of scaling already built into it, but if you need to scale it up for a very large system, it'll do that. So, and then of course InfiniBand and Slingshot and OmniPath and Ethernet, it'll gather the directions to make the link ups, but it'll do, for instance, if you got a CXL node over here, a CXL switch, it'll go through the Ethernet. It'll make the association go through the Ethernet, go to the CXL switch, gather this stuff for me, and then bring it all the way back to the left side. So there's a lot in this diagram. Events, for instance, if you have a flapping connection, let's say you had an InfiniBand connection on a large system and it's flapping, it'll go back to the event log, get communicated through to the client through the composability layer, and you can make decisions. Oh, drop this link, it's flapping, is there another way to get there? It'll do that as well. So we have, this is a kind of a breakup here. I was trying to make it obvious that the composability layer's got some information here too, but everything's a RESTful API. In our case here, you can go directly to the OFMF with its RESTful API, but a lot of these designs are going through the composability layer, and the composability layer you can do quality of service, you can get a resource inventory, so again, the stuff over on the left side, like in our case a container engine, can gather all that information. Authentication, some fabrics can and access control, so they'll give you things like exposure. Somebody might have a need to see something that somebody else doesn't see, they'll get that ability to do that too. So we've got, and we got composability managers, you got accelerators, container engines. In our case, we're looking at Kubernetes and Slurm talking to each other, and there's a container engine. So, come on. So who's participating in this? We have SNIA, obviously, the Gen Z consortium, or the CXL consortium, because it got kind of merged. And then we've got a large group of people, and it's all under the Open Fabrics Alliance. I'm the chair of the working group. So we've got good representation. We're getting help from the DMTF and et cetera, I think. That kind of puts it together. The Open Fabrics Management Framework is using all the pieces of everybody's pie there, and so what are we doing currently? So last year at SC, which is in November, we did a on-site demo, which nobody was at SC last year in person, but we did a demo. We did a birds of a feather session and stuff like that. We did a proof of concept demonstration using Gen Z, and I'll show you a little bit on the demo when I get to that. But a lot of it was taking chunks of memory and then making requests to the Gen Z fabric manager through the Redfish and Swordfish to associate memory chunks with resources. And then this year, we're working on a proof of concept demonstration for a CXL consortium. We're going to take, again, chunks of memory. That's a simple use case that we're starting with. And then we're taking Gen Z did some small chunks of memory and some servers and stuff like that. This year we're trying to do, with CXL, we're doing basically CXL 1 and 2 demonstrations. So we'll take and associate one memory chunk with one resource, and then for If everything works out good with that, then we're going to take CXL2, which is take two and break up one memory chunk into two different regions for two different servers or resource clients. And then, of course, you can always look at what we're doing with the code. Is checked in on GitHub, and it's open to everybody. There's only a few of us that are allowed to post changes to it, but you can pull it anytime you want to. We have 4 cloud servers right now that we started with, and we've got the code basically running up on those cloud servers, so we can do development work, and then as we get the development work done, we post it over here. So this is kind of our proof of concept demo. It's kind of hard to read there, but what we did was Russ took, and a few other guys took, and made requests using the Redfish and Swordfish API, through the API to the OFMF, reset the Redfish and Swordfish database, and then again, you can look at the actual demo there as you go, if you want to, on YouTube. But you can see things like, in this case, a reset. You can check memory domain status. You can see what you've got available for memory. In this case, you can see in bytes what everything was there available to use. And then you can list the memory chunks that are associated, who's using them, so you don't try to use a chunk that somebody else is using. And then, of course, you can check the connections, because we're a fabric management framework, so you want to see what your fabric connections are available to match the resources to the clients. And then once it's done, you can see, hey, this is what I've got, this is a chunk I've got, and this is who it's going to. And that's the end of my talk. It was a little short, but does anybody have any questions? Yeah. So we used the standard Redfish mock-ups for. I'll go back here. This is a little slow, sorry. Okay, so each one of these, went too far. So each one of these represents a mock-up. So you'd have the memory mock-up, you'd have the fabric adapter mock-up, and so on and so forth. And that's all represented, again, in the OFMF using the standard Redfish and Swordfish mock-ups. And you can look at those anytime you want to.
But where is the management, the fabric management interface? I didn't see it here, right? Fabrics?
Yeah, it would be, the fabrics, which would be another mock-up, but this is basically the components of whatever is in the OFMF. So if you look at the running OFMF and you make a request to it through the RESTful API, the mockup will pop out, basically in the structures.
And you have to mock up the Redfish website, right?
No, I don't. I don't have it displayed on the slides. I'm sorry, I didn't think of that. Another slide I need to add. Does anybody else have any questions? Okay, well, thank you.